Hi again. Today we are working with nonlinear equations and also talking a little bit more about functions. This lesson uses some things that by now you should have already learned. So if there's anything that you feel a little bit lost on, you may need to go back and review some of my other videos about graphing and functions and things like that. But otherwise, this section, it's really pretty straightforward and easy, I think you're going to find. The first thing that we need to check for is whether or not a table of values shows a linear relationship. For a line, it has to be constantly changing by the same amount, going up and over or down and over by the same rate of change every time. In other words, every time you check your slope between a pair of points, you should get the same answer. So that's what we're going to do. We're going to check our slope. Now, a very quick review here. Slope is rise over run. It's your change in y's over the change in x's. So I'm not just going to put 3 over -1, 6 over 0. I need to check what those values are changing by between the points. So on my y's over here, to get from 3 to 6, that's going up by 3. And to get from -1 to 0, that's going up by 1. So the first rate of change there is 3 over 1. The next one, 6 to 9 is 3. Whoops. 6 to 9 is 3. 0 to 1 is 1. So there's another 3 over 1. Finally, 9 to 12 is 3. 1 to 2 is 1. So there's another 3 over 1. If I would have gotten like 6 over 2 or 9 over 3, it would still be fine because they would all reduce to the same. So you find your slope. Make sure they all reduce to the same value. And if so, yes, it's going to be linear. Let's do another one. This one's also just a table of values. It's just set up horizontally instead of vertically. This one, to get from 1 to 4 is 3, and 1 to 2 is 1. So that's a change of 3 over 1. 4 to 9 is 5. 2 to 3 is 1. So that's 5 over 1. I can already tell those don't match. So this is a no. That one's not just a random relationship, though. That one's actually, if I graphed y equals x squared, because look, whatever I put in for x, if you take it times itself, then you get that y value. So that one you'll see a little bit later on in this video. It does make a certain kind of graph, but that graph is not a straight line. It's not linear. Okay. To determine if an equation shows a linear relationship or if the graph would be a line, you need to make sure that your variables are just plain old variables, no exponents. You should have already learned about negative exponents, fraction exponents for roots. So you can't have a variable on the bottom of a fraction. You can't have a variable inside a root, inside a square root, cube root, anything like that. And you also can't have it inside any other symbol where it would be like absolute value, hint, hint for when you see down there. All of those produce certain types of graphs every time. But if it's not just a plain old variable, it's not going to be a straight line. So the first one that I have there is good. It's just a y, it's just an x. The second one is a no because I've got an exponent on that variable. The third one is a no because the variable's on the bottom of a fraction. The next one is a no because it's inside the square root. And the last one is a no because it's inside an absolute value. It's only going to be a straight line if it's just a y and just an x. Okay? Okay, to decide if it shows a function. Now, a function doesn't have to be a straight line. It can be, but it doesn't have to be. So we're not going to check this in the same way. It doesn't matter if your slope is constant on these. What matters is that every x value is different. You cannot have any repeated x's. So focus just on your x values. All of those x values are different, so that one's fine. It's a function. These x values, look, I have a repeated 5. I could still graph it. It would make some kind of graph, but it's not going to be a straight line because it's not going to be a function. Sorry. See, now here I am messing up. It's not going to be a function because it has a repeated x. Sometimes they will be straight lines. but not all straight lines are functions. For example, this next one here, 2.8, 2.7, 2.6, if you graph those, so if I go over 2 and up to 8, so that's up here somewhere, 2.7, 2.6, 2.5, those are all a straight line. That's linear. But I'm going to show you in a minute that that doesn't pass something called the vertical line test. That is not a function. You have all these repeated x values, so that one's a no. The last one, if you plot those, it's a horizontal line. Now, a horizontal line is okay. It doesn't matter if you have repeated y values. The y values can do whatever they want. It's those x's that you want to focus on. And all the x's in this set of points, they're all different. So that one's good. It's a yes. Okay. So determine if the graph is a function. I haven't put my graphs on here yet because I figured I could kind of explain it as I was showing you. So we have on this first one, let's just do a linear graph. That one would have a positive slope. There's something called a vertical line test. Vertical is up and down, right? So what this says is if you run a vertical line through your graph, anywhere on the graph, it can never hit the graph at more than one point at the same time. It doesn't matter on this one. Like if you take a ruler or your pencil and run it across, it doesn't matter where on the graph you are. It only hits that line that I graphed one time. So this one is fine. This one is a function. It doesn't matter if it's slanted up or slanted down, just a normal line graph like that where it does have either a positive or negative slope, then it's good. I mentioned in the slide before this that not all linear graphs are functions. Now, a horizontal one is okay. So I've got this horizontal line. This would be y equals 3 because every y value is at 3. If you run a vertical line across here, it doesn't matter where on the graph you are, you're never going to hit that line in more than one point at a time. So this one is fine. This one is also a function. But when you have repeated x values, so for example, if you have a vertical line, even though it's linear, it's not a function. If I do x equals 4, so it's a vertical line over here where every x is in line with 4. If you run a vertical line across that, obviously it's not going to pass the test because it's hitting an infinite number of points at one time. If you do, so let me draw in a vertical line. If I run a vertical line over this, I mean, look at all these points that it hits at the same time. It fails the vertical line test. That's why that one is a no. Sometimes curved graphs can be, not always. For example, if I do y equals x squared, so y equals x squared, let's see, 0, 0, put in a 1, 1 squared is 1, put in a 2, 2 squared is 4, put in a 3, 3 squared is 9, that's up here somewhere. Negative 1 times itself is 1, so you have the matching counterpart over here on all these. But if I graph that, it's this curve, it's this U shape, it's called a parabola. And it doesn't matter where I run that vertical line, I only hit that curve, that parabola, in one place at a time. That one passes the vertical line test. So this one is good. It is possible to have that same kind of curve, but instead of it being where it opens up vertically like that, it could open up sideways. So let's see, let's do the exact same points, but just make them opening sideways instead of vertically. So here's my sideways curve. Whoops, that point should have been down here. My hand was kind of in my own way. It doesn't really matter though, because you're gonna get the point here. When I do a vertical line, look, there's all these times when it hits in more than one point at a time. And that's what makes it fail the vertical line test. So you can pick any vertical line as an example. If I just show you this vertical line here, it hits in two places at the same time because you have that repeated X value. So that one fails. So think about running your finger, your pencil, a ruler across it. If you ever hit the graph in more than one point at a time with that vertical line, then it is not a function because it fails the vertical line test. The last thing I want to show you is how to graph some of these nonlinear equations. The easiest thing to do right now is just to make a table of values. You want to make sure that you pick some negatives and some positives so that you can really see what's going on both sides. So I'm going to do, it doesn't matter what order I put them in the table. I always do 0, 1, and 2. And then I do their negative counterparts as well. So I'm going to do a -1 and a -2. If it bugs you that I didn't write them in order from smallest to biggest, I'm sorry. You're welcome to do it however you want. But all the points are going on this graph anyway, so it doesn't really matter what order you put them in. If I put in a 0, so I would take 0 squared minus 1, I get -1. So I have a point at 0, -1. If I put in a 1, I'd have 1 squared minus 1. That would be a 0. So I have a point at 1, 0. If I put in a 2, that would be 2 squared minus 1. 4 minus 1 is 3. Whoops, I forgot to write that down. I would get a 3. So I've got a point at 2, 3. If I put in a -1, now -1 squared is still a positive 1. Positive 1 minus 1 is 0. So that's a matching one right here. It makes it like I've got a line of symmetry. It's symmetric on the left and the right. If I put in a -2, -2 squared is 4. 4 minus 1 is 3. So I have a point at -2, 3. So here's that parabola. Here's that U shape. Anytime you have an x squared, it's going to come out to be one of these parabolas. It may be shifted up, down, left, or right, but it's going to be one of these U shapes. Okay, so there's that graph. If I had been asked if it was a function, the answer is yes, because it passes the vertical line test. If I was asked if it was linear, no, because it's not a straight line, right? Okay, I've got two more. Y equals -x squared. I'm going to do those exact same points. And here, I'll put them in order this time in case that makes anybody feel better. I know sometimes when things are out of order and don't look right, it can just make you feel like a crazy person. Maybe that's just me. No, I don't know. So the x with the exponent is not actually with that negative sign, if that makes any sense. I said that in a very confusing way. The negative sign is not in parentheses. So this means opposite of. Order of operations, you have to do your exponent first and then change the sign, then write the opposite of it. So if I put in a -2, -2 squared is 4, and then I need the opposite. So that's a -4. If you put in a -1, -1 squared is 1, and then I need the opposite. That's a -1. 0 squared is 0, and then the opposite. So that's still just a 0, right? You can't have a -0. If I put in a 1, 1 squared is 1, opposite is -1. If I put in a 2, 2 squared is 4, opposite is -4. Because this was x squared, I already knew that it was going to be a parabola. It's going to be a U shape. But what happens is that negative on the outside, it flips it upside down. So it's an upside down U. So I have a point at -2, -1, 2, 3, 4. Oh, come on, little stylus. -2, -4. I have a point at -1, -1, 0, 0, 1, -1, and 2, -4. These are supposed to be curved, so try not to make it too V-shaped. I know it kind of naturally comes out looking like that. Try to give it a little bit of a curve up there. Let's do one more. Y equals 1 over x plus 2. This one's really weird because I cannot put in a 0. Anybody know why? You should have learned that 0 on the bottom of a fraction doesn't exist. So you'll learn more about, the parts, the attributes of these graphs as you get older. But that means I'm going to have like a little empty part in my graph. I'm going to have something going on the left and something going on the right, but I am not allowed to put in a 0 because 0 cannot be part of that equation. So let's pick some values. Whoops, x, y. I'm going to do a little bit more this time because I know I can't put in 0. So I'm going to do like -4, -3, -2, -1, and then I'm going to do 1, 2, 3, 4 so that I can really get an idea of what's happening. If I put in -4, that becomes -1/4 plus 2 would be 1 3/4. If I put in a -3, that'd be -1/3 plus 2 is 1 1/3. If you put in a -2, that's -1/2 plus 2 is 1 1/2. And if you put in a -1, that becomes -1 plus 2 is 1. So let's see what's happening there. I've got -4, and then I'm going to go up 1 3/4 of the way to another. -3. I'm going to go left 3, up 1, and then just a little bit over that for a third. Oh, it should be 1 2/3. I was like, wait a minute, that doesn't make sense. Oh, you guys, I'm so sorry. If you put in a -3, it's -1/3, right? So 2 minus a third, you have 1 2/3. I say, wait, this is not what my graph is supposed to be doing exactly. So that's -3, 1 2/3. It's a little bit below 1 3/4. -2, 1 1/2 is a little bit below that. I know my points are so close on this graph, it's really hard to see because I made that second point too big, so it kind of looks like they're all running together. -1 and 1. What happens is, if you put in a half so that you can really see this, if you do -1/2, so 1 divided by -1/2 is going to equal -2. -2 plus 2 is 0. So it curves right here. So this ends up being like this weirdo little curve like this. And now if I put in my positives, why did I put them on the y side? What in the lands did I decide to do on this? Do. Oh my goodness. Why did I do that? Because, I know I did that. Because I said on the right side, let's do 1, 2, 3, 4. So then dingling me decided, let's write it on the right side. No, I'm plugging it in for X, not for Y. My goodness gracious. Okay, if I put in a 1, 1 over 1 is 1. 1 plus 2 is 3. If I put in a 2, 1 over 2 is a half. Plus 2 is 2 1/2. Oh my gosh. One of these days, I'm going to make a video without doing or saying something stupid. Maybe. If I put in a 3, that'd be 1/3 plus 2 is 2 1/3. And if I put in 4, 1/4 plus 2 is 2 1/4. Let's see what that looks like. So 1, 3, 2, 2 1/2. If I put in 3, I get 2 1/3. So a little bit less. 2 1/4. This one ends up swooping down like that. So the main thing to know on this one is that you can't have zeros, so you have to have this break. Okay, I know that was a tougher one. I wanted you to see kind of what these different graphs looked like. When you get into high school, you'll learn a lot more about what always happens when it's an x squared or an x cubed or an absolute value or a square root or the x on the bottom of a fraction. But I wanted you to see something different and kind of get some practice with plugging values in. So as a seventh or eighth grader, what I would expect you to know on like y equals 1 over x or whatever it may happen to be when you've got, oh my gosh, now my little thing disappeared. There we go. When you've got x on the bottom. Oh, now my stylus isn't going to write. Everything just like froze up. I hope you guys can still hear me okay. Like everything seriously froze. So that's cool. Awesome. It's not going to let me write anymore. Like it's just gotten really mad at me. Okay, so we'll just talk. It's fine. What I would expect you to know as a seventh or eighth grader, when you are graphing with x on the bottom of your fraction, you need to make sure you know that you cannot plug in a 0. And then even if you just put in a couple values just to kind of give yourself an idea of how that curves, just know that it can never, ever hit that y-axis where x equals 0. Okay? Yeah, boy, everything's just totally frozen. Okay, so it's not even going to let me show you my end screen, but that's okay. Until everything went haywire here at the end. Hopefully that kind of made some sense. Let me know if you have any more questions. Subscribe to my channel. You can make a comment on this video, or you can reach out to me at my school email. It's ajl4@vigoschools.org. Sorry for the technical difficulties here at the end and, a couple stupid mistakes. This is real life, right? Thanks so much for sticking it out. Love you all. Bye.